Ready for a deep dive into some seriously cool stuff in space? Today we're heading straight for Jupiter's rings, which are,
Oh, they're fascinating.
yeah.
Yeah.
I bet most people, they hear Jupiter's rings and they think, oh, like Saturn's. But,
Right, exactly. Everyone always compares them to Saturn,
right.
but they're really their own unique thing.
Yeah. So tell me more about that. What are we going to learn about today?
So, we're going to look at some awesome research papers that'll help us figure out how these rings even formed, plus what they're made of. That's always cool, right? And get this. We might even uncover clues about what Jupiter was like way back when, like billions of years ago.
Wow. Okay.
Uh,
So Jupiter's rings, we're not just talking about like one thin band, are we?
No, definitely not. Jupiter actually has a whole system of rings. There's the main ring, obviously, but also the halo ring, and not just one, but two gossamer rings. And they're actually named after moons, Amalthea and Thebe. If you want to see what this whole system looks like, check out Figure 6.1 and Table 6.1 in the 1T07.00806V2.pdf paper. It's a great visual.
Okay. Gossamer rings. I am already picturing something super delicate and beautiful.
Oh, they really are.
Yeah.
Especially when you see them in some of the images.
But okay, do they all look like Saturn's rings? Like kind of smooth and flat?
That's a great question. It actually depends on how you look at them, especially the main ring. It all comes down to how light is scattered. So think about shining a light on something dusty, right? The light that bounces directly back at you will look way different than the light that sort of scatters off in other directions. Scientists use the same idea to study Jupiter's rings.
So by looking at the rings from different angles,
Yeah,
they can tell different things about what they're made of.
exactly. For example, Figure 6.3 in that same paper, it shows the main ring in two ways. Forward scattered light, which makes it look really smooth, and back scattered light, which reveals all these complex structures. That's how we know there are probably larger objects inside the ring that we can't see directly, that are kind of the source of all these smaller visible particles.
Wow, so they're like space detectives, piecing together clues from these different types of light.
That's a great way to put it.
But how do they even study something that's so faint and so far away?
Well, they've got some pretty high-tech tools up their sleeves. One of the coolest is called adaptive optics, which basically gives telescopes like supervision. It corrects for the blurriness our own atmosphere causes and gives us way clearer images.
Oh, right, because our atmosphere can really mess with things.
Oh, absolutely.
Okay, that makes sense. Sharper images, more clues. Now, you mentioned a halo ring earlier. What's special about that one?
So unlike the main ring, which is flatter, the halo ring is more like a puffy donut shape, a diffuse cloud of particles. Plus, its brightness changes depending on how far away you are from the ring plane, with most of the material concentrated near the center.
Okay, that's such a unique shape for a ring. What makes it do that?
Well, scientists believe those halo rim particles were actually once part of the main ring, but then they got kind of nudged into this different orbit by Jupiter's super strong magnetic field. It's like a cosmic tug of war going on, you know?
Between the magnetic field and gravity,
Exactly.
and the magnetic field one creating the halo. So cool. Now, does the color of the rings tell us anything?
It does. It's actually a really important clue. See, the parent bodies inside the rings, those are like the bigger chunks that the ring material probably came from. Those are kind
Yeah.
of reddish. But the halo, it has more of a bluish tint.
Oh, interesting.
And that difference suggests that the parent bodies and the dust in the halo don't have the exact same composition. It tells us something about how the ring material has changed over time.
Huh. So even just the color can reveal a lot about these rings.
It's amazing what you can learn by paying attention to those details.
Now, earlier you said something about the rings being like cosmic fingerprints. What did you mean by that?
Ah, yes. One of the coolest things we've found are these really faint ripples within the rings, especially in the main ring. And guess what? Scientists think these ripples are actually traces of impacts from comets that have flown a little too close to Jupiter.
Wait, so like comets leave marks on the rings, like graffiti, but cosmic.
Exactly. When a comet gets too close, it releases all this dust and debris, right? Well, that debris slams into the ring particles and creates those ripple patterns. So by studying these patterns, we can actually retrace when comets have hit the Jupiter system. It's like reading the rings for clues about past events.
That's incredible.
It's so cool. And figure 6.9 in the paper actually shows some of these impact ripples. There are two distinct patterns, which means there were two separate comet encounters that we can see evidence of.
Wow. We're going to need to talk more about that. But first, what about those gossamer rings? What are they like?
They are absolutely captivating. Have you seen the false color mosaic that the Galileo spacecraft captured? It's figure 1 from the Bernsettel 1999-1146.pdf paper. You can really see just how faint and wispy they are against, the backdrop of space. It's stunning.
Okay, adding that to my list of space pictures to look up later.
You should. It's gorgeous.
Okay, but how do such faint rings even form? Are they made of the same stuff as the main ring and the halo?
So we think the Gossamer rings are mostly dust that's been ejected from the moons Amalthea and Thebe, and this is happening all the time. As these moons get hit by micrometeoroids, they release these dust particles, and then, because of Jupiter's gravity, that dust gets captured and forms these ethereal rings.
It's like a never-ending cosmic dust storm around these moons. That's so cool.
It's a very active system, that's for sure.
And why are they so much fainter?
It's probably because the dust in the Gossamer rings is much finer, much smaller than the particles in the other rings, so they don't reflect as much light. It's like the difference between, I don't know, like a mirror reflecting light versus like a piece of paper. The mirror is going to be much brighter.
Oh, that's a good analogy.
Yeah.
Because I was looking at figure 2 from that paper, and I noticed that the Gossamer rings actually seem brighter at their edges. Is that just like a trick of the light, or is there a reason for that?
Oh, that's a great observation. It's not a trick. It's actually all about how the particles are moving within the rings. So picture a spinning top that's about to fall over, how it wobbles in this particular way.
Yeah.
Well, the particles in the Gossamer rings, they have this similar kind of motion. It's called epicyclic motion, which is a mouthful, but basically it means they bunch up at the edges, which makes the edges look brighter.
So it's all about the physics, those wobbly particles.
Exactly. Physics is so cool.
But if they're always being ejected from the moons, shouldn't the Gossamer rings just keep expanding outwards forever?
Okay, so this is where things get really wild, and it all comes down to the incredible forces at play in the Jupiter system. These dust particles aren't just being influenced by Jupiter's gravity, but also by the planet's shape. It's actually slightly squashed, which we call oblateness, and by the electromagnetic forces from Jupiter's magnetic field, too. So you have all these forces, plus the pressure from sunlight, and they create this kind of balancing act that determines what happens to those dust particles.
So it's like Jupiter's conducting this massive cosmic orchestra with all these forces playing a part.
I love that. Yeah, and some particles get flung inwards, some get pushed outwards. It's all there in figure 3 from the paper. That interplay of forces is visualized beautifully.
Okay, that's incredible. It's not just a pretty picture, it's a map of all these forces.
And it tells us a lot about the delicate balance of everything going on around Jupiter.
It really puts things into perspective. But we've talked a lot about the rings themselves. Can we actually learn anything about Jupiter by studying them?
Absolutely. In fact, one of the most exciting things about these rings is that they can actually give us a unique glimpse into how Jupiter formed and what's going on deep down inside.
Wait, hold on. We can learn about the inside of Jupiter just by looking at its rings.
You got it. It's all about figuring out what Jupiter is made of. So we know it's mostly hydrogen and helium, the lightest elements out there. But there's this puzzle about how much heavier elements are in there, too. Astronomers call these metals, but, and I know this is confusing, they're not solid metals like we have here on Earth,
So we're talking about elements that are heavier than hydrogen and helium.
Exactly. Things like carbon, nitrogen, oxygen. Figuring out how much of these are inside Jupiter is huge because it tells us how the planet formed. Like, was it a slow, gradual process or a more sudden collapse?
So the more of these heavier elements, the more complex the story of how Jupiter came to be.
Exactly. And the rings can help us solve that mystery. Isn't that amazing?
Yeah, so by studying these rings, we can decode the recipe for how Jupiter was made. But how exactly do the rings connect to what's happening inside the planet?
Okay, so buckle up because this is where things get really, really cool. One of the key clues lies in this phenomenon called helium rain.
Helium rain. Is it literally raining helium inside Jupiter?
You got it. Deep inside Jupiter, the pressure and the temperature are so intense that helium actually separates from hydrogen and forms these droplets like rain falling through the atmosphere.
Whoa, it's like a constant drizzle of helium?
Yeah.
But like deep inside Jupiter. How does that even affect the rings, though?
Okay, so that helium rain, it has a huge impact on Jupiter's internal structure and its gravity, which in turn influences how those ring particles behave.
Okay, so it's like a chain reaction.
Yes.
The helium changes the insides, which changes the gravity, which affects the rings.
And because we can measure Jupiter's gravity really, really precisely, Scientists can then use that to figure out details about the planet's internal structure, including where this helium rain is happening and how those heavy elements we talked about are distributed. It's like reverse engineering a planet.
That's incredible. Is there like a visual for this helium rain, like in the papers we're looking at?
There is Figure 2 from the Hubbard 2016 APJ 82080.pdf paper actually shows where this helium rain layer might be based on really complex computer
Oh,
models.
wow. It's like we're using these rings to unlock all these secrets about a planet that's like millions of miles away.
It's amazing, isn't it?
But wait, there's more. Right. We also have to talk about Jupiter's atmosphere, because that plays a part in all of this too.
Oh, absolutely. It's a key player for sure.
So what's the connection between this incredibly dynamic, turbulent, colorful atmosphere that we always see in pictures
Right.
and the rings?
So the composition and even the behavior of Jupiter's atmosphere can actually affect the rings in subtle ways.
Mm.
For example,
Acetylene.
like for welding torches. Exactly, C2H2. Scientists have found that it's way more abundant in the northern hemisphere of Jupiter's stratosphere compared to the south.
That's weird. Why is that?
It probably comes down to how gases mix in Jupiter's atmosphere, specifically these large-scale atmospheric waves called Rossby waves, which are kind of like,
Like jet streams?
yeah, kind of. And these waves, they can move gases like acetylene around, which might explain why we see this uneven distribution.
Okay, so Jupiter's atmosphere is kind of playing favorites with its gases.
You could say that.
And this uneven acetylene, does it affect the rings in any way?
You know, that's a fantastic question, and it's something that scientists are still trying to figure out, but it's definitely a possibility.
Man, everything is connected.
The Jupiter system is all about these fascinating connections.
Are there any other atmospheric gases that are acting up, so to speak?
Oh, absolutely. Another one is ethane, or C2H6. Now, you'd think it would be more abundant in the parts of the atmosphere that get more sunlight, right? Since sunlight provides energy for those chemical reactions.
Yeah, that makes sense.
But guess what? Observations show that ethane actually increases toward the poles of Jupiter, where sunlight is weaker. It's a real head-scratcher.
No kidding. So even the gases are full of surprises.
It really goes to show how incredibly complex and dynamic this whole system is. It's like a never-ending puzzle.
And Jupiter likes to keep things interesting. It sounds like we've got a lot more to uncover about this planet and its intriguing rings.
Oh, we're just getting started.
It's amazing how much complexity is packed into Jupiter's ring system, even though they're so much fainter than Saturn's. It's like comparing a whisper to a shout. Both can tell a story if you listen closely enough.
That's a great way to put it. And, you know, studying these fainter rings can actually give us a unique perspective on how ring systems form and evolve, not just around Jupiter, but around planets in general.
Really, what makes Jupiter's rings unique in that sense?
Well, we've talked a lot about Jupiter's powerful magnetic field, right?
Right, it's massive.
It's a major player in shaping the rings, influencing the charged dust particles in ways that we don't see as strongly with Saturn's rings. It's like Jupiter's magnetic field adds another layer of artistry to the cosmic dance.
So Jupiter's magnetic field is like a sculptor, shaping the rings in ways that other ring systems haven't experienced.
Exactly. And then there are Jupiter's 4 largest moons, Io, Europa, Ganymede, and Callisto, the Galilean satellites. These moons are massive, and their gravity can stir things up in the rings.
Ah, so it's not just Jupiter itself influencing the rings. Its moons are part of the equation too.
You got it. The gravitational pull of these moons creates ripples and waves in the rings, like the wake of a boat moving through water. And by studying these disturbances, scientists can actually estimate the masses of these moons and refine our understanding of their orbits.
It's amazing how much information is encoded in those seemingly simple rings. It's like a giant cosmic laboratory for studying gravity and orbital mechanics. But it's not just a one-way street, is it? Do the rings have any effect on the moons themselves?
They do. Remember how we talked about the dust from the rings contributing to the thin atmospheres of Jupiter's moons?
Right. It's like a constant cosmic drizzle enriching their exospheres.
Exactly. It's a great example of how interconnected this system truly is. So, while the rings might be small compared to the moons, they definitely have a role to play in the bigger picture.
This has been incredible. I feel like we've zoomed in from these tiny dust particles to a grand scale view of the entire Jupiter system. But let's zoom out even further for a moment. What can Jupiter's rings, and ring systems in general, tell us about the formation of planets and solar systems?
That's a really important question. Jupiter's rings, along with those of Saturn, Uranus, and Neptune, are like time capsules, offering glimpses into what our early solar system might have looked like billions of years ago.
So the rings are like fossils from the early solar system.
Exactly. By studying their composition, structure, and how they behave, we can gather clues about the conditions that existed when planets were first forming. It helps us understand not just how our own solar system came to be, but potentially how planetary systems form across the universe.
That is absolutely mind-blowing. It really highlights how interconnected everything is in astronomy. These tiny, faint rings around Jupiter can unlock secrets about events that happened billions of years ago, shaping the universe as we know it.
You said it. It makes you appreciate the power of scientific observation and the incredible scale of the cosmos.
It really does. Well, I think we've successfully navigated through a pretty dense cloud of information about Jupiter's rings. We've journeyed from their unique structure and composition to the clues they hold about Jupiter's formation and the evolution of planetary systems.
It's been a pleasure diving deep into these fascinating structures with you.
It's wild to think that these rings, as tiny and as faint as they are compared to something like Saturn's rings, can tell us so much about, like, the entire history of our solar system, maybe even the universe.
It really puts things into perspective, doesn't it?
It does. But we haven't really talked about that part yet. What can we learn about planets and solar systems in general just by, like, looking at rings?
Okay, so imagine this. Jupiter's rings, along with those of Saturn, Uranus, Neptune, they're all kind of like time capsules, giving us these glimpses into what our solar system might have looked like billions of years ago, way back when planets were just starting to form.
So the rings are like fossils, but space fossils.
Yeah, exactly. By studying their composition, how they're structured, how they behave, we can piece together clues about what the conditions were like back then. It's not just about understanding our own solar system, but maybe even how planetary systems form all across the universe.
That blows my mind a little bit. These tiny, faint rings around Jupiter could hold the secrets to, like, the biggest mysteries in astronomy.
It's pretty incredible when you think about it that way, right?
It is. Well, I feel like we've done a pretty thorough job of exploring Jupiter's rings today. From their unique structures and what they're made of, to the clues they hold about Jupiter's formation, and even the evolution of planets and solar systems.
It's been a blast.
And for everyone listening, we hope this deep dive has left you just as awestruck as we are. The universe is full of incredible stories just waiting to be discovered. Keep looking up, and we'll catch you in the next deep dive.